Okay, one of the most important things to do when loading an event data is to make sure that the event data is actually good. This involves loading the data in and basically inspecting the entire data file, sort of running through the entire thing from end to end to make sure there's no bad events. I'll show a simple example of this, and I'll show it by unchecking the box of Remove Bad Events. This will be a simple stream mode data, not oscillatory. So I'll load event log file, and this file is a fairly small file, only a few megabytes in size. But when I open this up, the first few events look sort of odd. The time does not go straight from 0 to 26 seconds. It was, again, a short data collection. But what's noticeable in the differential is some very large spikes above and below 0. These are indicative of jumps in the time. This can happen where, in this case, you can see the first few events are mis-encoded, and then if we go to Editing and Adjust Events and select All Data, we can see that there's been a few mis-encoded events along the data stream. These are obviously not correct. If we plot the differential along with it, we'll see that the differential lines up correctly with all of these spurious events. One way of getting rid of these is to have it automatically find outlying points, and it places both cursors at a particular point. And if we zoom in here, and we will have to zoom in quite a bit, since again this is a short data file, but there are still more than 200,000 data points here to work with. So if we select a region, click in it, and expand, we can keep blowing this up to the point where we can actually see what's going on. And what we see is there's 4 data points here that are incorrect. And if we drag and drop the cursors to those points, we can then trim points, and it will inclusively trim those data points out of the data file. If we then look at all the data again and then recalculate the differential is now correct there, and we'll see there's still a few points where the data is incorrect. Again, if we expand in on this, and one more time, if we drop the cursors on the black trace, which is the event data, as long as you're close to that point, it'll put it to the nearest point. So you don't have to be right on it. And what you'll notice is that actually this level here is about, if I show the cursors, it'll show what the actual, oops, moved them to the beginning and end. It'll show what these point values are. And in fact, the time value is 20.1 seconds. And if we drop down to one of the lower points here, we see the low value here is 13 seconds. The high value is 20 seconds. The differential is 6.7 seconds, which is in fact a single rollover event, which is as far as the counter can accumulate time, which is 6.7 seconds. So what happened for these 5 data points is the rollover event was missed when the data was collected, and so was incorrectly read from the data file. If we want to, we can either delete these points, or we can actually subtract this incorrectly added 6.7 seconds by saying subtract time, and that will subtract time between the cursors, dropping these values to their correct level. It's up to you whether you want to delete the points or adjust the times. It really makes no difference because this is 5 points out of 200,000. Now what you would want to do with all of this data is, again, adjust all the data points here. There's a few more to adjust. And if we do the same here, and adjust these data points, subtract the time, And then for these final data points at the beginning of the data set, if we simply get rid of these from point 0 to that data point, we trim those points out, then all the data will be good at this point. Do the differential, and now the differential is simply sort of jittery, mostly around 0. We save this, and this is our new data, corrected, and then this data will, again, the next time we load it in, will be correct. We can process this now correctly, and it shows proper binning of the data. And now instead of loading in the incorrect event file and having to reprocess it and readjust it every time, we can import an edited file, and it will look for, in this case, the data that we just corrected, and then simply be able to load it in correctly, and there'll be no spurious signals in the data file. For most cases, if we check remove bad events and load the event log file in, we can get most of these bad events cleaned out automatically. And in fact, that's what's done. The differential now looks very much like what we saw before. And then the events versus time here is this nice smooth stream without the spurious signals. So for, again, for most events, it'll automatically remove them, but there are certain events where it's just not automatically detected and needs to be removed manually. But you will want to make sure that you look at the entire data set and make sure that the maximum time, the maximum collection time, or the maximum time of your oscillation period does match with what you expect from when you collect the data. Because if it doesn't, that can indicate mis-encoding of the data. And again, this is mis-encoded at the time of acquisition, so it can only be touched up afterwards.